Hi guys, Miss Francis here, and I would like to continue our discussion about enzymes. Enzymes are proteins. Because they are proteins, they need to maintain their shape in order to do their function. That shape, however, can be influenced or affected by external components such as pH, temperature, substrate concentration, enzyme concentration, salinity. All of those external factors can play a role in the effectiveness of an enzyme's ability to speed up a reaction. So the rate that a specific number of enzymes converts substrates to products does depend on the substrate concentration. So let's take a look at this graph. Initially, if I have increasing substrate, the rate of the reaction is going to increase because I have more substrate for the enzyme to break down. However, at some point, the rate of the reaction is going to level off because all of my enzymes are being used. It doesn't matter how many more substrates I add, there aren't any enzymes available to either break them down or build them up. The only way I would be able to increase productivity at that point would be to add more enzymes to that situation. When you have some time, see if you can match the letters to the statements within the graph and understand why those letters match to those statements. Temperature is another factor that's going to have an impact on the rate of reaction of an enzyme, the rate of a chemical reaction. Whether temperature increases or decreases, that is going to have an impact on the rate of the reaction. So let's address temperature increasing. As it increases, my molecules move faster, so there are more frequent collisions between my enzymes and my substrates. Therefore, the reaction is going to occur faster. However, there is something called an optimum temperature at which the enzyme is working at its fastest rate, or the reaction is occurring at its fastest rate. And after that temperature, at higher temperatures, my enzyme is going to denature. It's going to unravel. If my enzyme denatures, it has changed its shape. And why does it change its shape? Because the bonds, the ionic bonds, the hydrogen bonds, the hydrophilic and hydrophobic interactions, the van der Waals forces, the disulfide bridges are being broken down, and my enzyme can no longer maintain its shape. If it doesn't have that shape, it can't fit into the substrate. If it can't fit into the substrate, it cannot help that chemical reaction along. Another factor that's going to influence the rate of reaction is pH. And similar to temperature, pH is going to have an optimal, or each enzyme is going to have an optimal pH at which the rate of the reaction is going to occur the fastest. For most enzyme, that occurs between 6 and 8. There are some exceptions to this rule. For example, our digestive enzymes in the stomach. So pepsin has an optimal pH of 2. That is the pH at which the digestive enzymes are going to work best. Trypsin, another digestive enzyme, is going to work at best at a pH of 8, however. And you'll notice that beyond those pHs for either one of those enzymes, our enzyme begins to denature and our rate of reaction starts to decrease. Another factor that's going to increase, or affect our rate of chemical reaction is salt concentrations. So just as the enzymes are affected by the charged hydrogen and hydroxide ions, which comes from pH. So when I have a lower pH, it's because I have more hydrogen ions. When I have a higher pH, more basic, it's because I have more hydroxide ions. So just as the enzymes are affected by charged hydrogen and hydroxide ions, they're going to be affected by the charged salt particles, because those charged particles are going to interact with the charged R groups, thus disrupting the interactions that were once going on. And there will also be an optimal salt concentration for each enzyme. Here's a quick little video by Stephanie Castle that discusses some of these factors. And I just wanted to give you a classic example. Eggs are a classic protein. They're made up of albumin. Normally, in its native state, an egg is a liquid. However, when I change external factors such as temperature, pH, even the pressure, my egg changes, my enzyme in the egg changes, and I can no longer bring it back to its native state. So what I mean here is my egg has been fried, meaning I have completely unraveled my protein and I can no longer renature that protein. However, when I look at warmed milk can potentially be brought back to its original active protein. So that's going to end the discussion regarding enzymes for today, and we'll finish up enzymes tomorrow.